He, yeah. Did they actually show who's playing him yet?
Yes.
That
I don't know what it is.
Who's?
Weird though.
What's the actor's name? What's he been in?
Hunger Games. You know the guy who played Hamish?
I didn't see any of the Hunger Games. So.
Yeah, they're using him. He's wearing this really. He's wearing this like bright. Yeah.
Woody Harrelson is going to be.
Yeah, he's wearing this bright red like curly wig.
Really?
Yeah, his hair.
Oh, that'd be interesting.
It's weird.
they did.
I like Woody Harrelson.
They did really good with Eddie Brock, so
Yeah.
really care.
I mean, it was definitely a step. Just from what I've seen in the trailers, it's a step up from Spider-Man 3.
Oh, definitely.
So yeah, I mean, for Spider-Man 3, they just tried to shove too much into one movie,
Well,
and it just
they didn't really want to add Venom, but they.
yeah. They shouldn't have even added Harry just yet. I think if the movie had been received better, there probably would have been another one with Tobey Maguire, but I think that kind of just derailed it for a while. You know. I mean, it's hard to believe, but you don't want to get typecast. I mean, what's his name? Chris Evans? Isn't he almost done playing Captain America? Yeah, we're still talking. Yeah, so you haven't missed any math yet. Okay, but just very quickly, let's say that this missing side here is B. So we have. Let me do it over here. That side seems to be a dead zone sometimes. So 13 squared plus B squared is equal to 85 squared. So B squared is equal to 85 squared minus the 13 squared. We take the square root. So we got B is equal to 84. Okay. So that's what's going to happen coming up on tomorrow. I'm going to give you another one of these. You'll find the missing side. Then just go ahead and list all the ratios for me. Now, there is something coming up this week on Thursday. What is it? It's your exam. Now, remember on your exam, you can always use your notes or any materials that you have except for, each other. But I'm going to go ahead and move it to Friday. I'm going to move the test to Friday because I want to give us an additional day to go ahead and practice and make sure that we don't need to rush through the lesson. We feel comfortable with it, and we're ready for the test on Friday. So everyone else, all those other classes will test on Thursday. I'll test you guys on Friday. Okay, so that is one of the big items. The other one is for that test, a big part of it will be evaluating functions, kind of reference angles. So if anybody is still needing a little bit of help with those, I did upload today. So if you look at the current week, trig functions, evaluating, and reference angles, I've got a whole bunch of extra examples here, and the answers are there as well. So just another little addition to help you prepare for the test. If you wanted to print that off and use it, I mean, it technically could be used as notes. There's one other item that I want to go ahead and talk about, and that is this paper that you picked up today. We're going to be doing a project on the unit circle. It's nothing too horrible, but I think it'll give you practice with it. I'm going to record it as a test grade, so it'll go ahead and give you another really good grade before the end of the 6 weeks, which is next Friday. So we have less than 2 weeks before the second 6 weeks is already done. In fact, including this week, we only have 4 weeks until Thanksgiving break. So it's going to start going, pretty quick. So here's what we're going to do. It's got to be on poster board. Okay, we're going to draw the unit circle, and it has to include all 3 items, that being the degrees, the radians, and then the coordinates of each point. Now, somewhere else on the poster, after you go ahead and draw the complete unit circle, I want you to draw 5 other circles. Okay, now we can't use the quadrantals, but any of the other 12 points on these, I want you to choose 1 point for each of the 5 circles that you created. And then you're going to show me using a right triangle, just like we did in class, how you get the coordinates of that point. And I'll show you what I mean in just a second. All right, you want it to be neat. Make sure your angle measurements are precise. If you're having trouble, let me know. Be creative with it, because that is part of the grading rubric. So let's say this is one of your 5 circles. Okay, they use this point here, located at 135 degrees. It's also at 3 pi over 4. So you see how, just like we did in class, they dropped a segment and created a right triangle? Okay. What you're going to want to do is talk about that special right triangle and then show me how we get the coordinate at this point. the square root of 2 over 2, comma, square root of 2 over 2. Now, this is just an example, okay? So I want you to go ahead and use any of the other 11 points that we have, because this one has already been done for you. So you'll go ahead, and this right here, I would say this is overkill. You don't have to write that much, but just enough for the reader to go ahead and understand why that particular point is what it is, okay? So let's take a look here. Here's your rubric. In fact, you'll notice the first 4 boxes, the main circle covers most of the poster board, so your unit circle has to be the largest circle on it. We're going to do everything on just one side. And then the other 3, degrees, radians, and coordinates. So just by putting on the largest circle and completely filling it in right there, you've already got all those boxes checked. And then the unit circle angle measurements are accurate, okay, meaning the spacing, is correct. Did you go ahead and draw the 5 extra circles? Just drawing the 5 extra circles would get you a check mark. All derivations were drawn by dropping the perpendicular line towards the x-axis. So remember, on each of those 5, you're going to choose a point in each one, draw a right triangle, and show me how we get that point using the special right triangles. There's a box right there, identifying it as a 45, 45, 90, 30, 60, 90. So it's really easy to check these boxes off. Okay, in fact, you should be turning it in knowing exactly what your grade is going to be. Okay, neat, colorful, and creative. All the math is correct, in that little area where you go ahead and talk about it. So it's going to be anywhere from 0 to 10. I'm expecting to get a lot of 9s and 10s, and I'm going to record this as a test grade. Normally, we only have 2 tests per 6 weeks. And with the category at 30%, they're 15% each, so those are the largest grades. But by doing this, it'll give you some practice on the unit circle, and all 3 of your tests will only count 10%. Okay, so if maybe you scored a little lower on one of your tests than you would like, and that's affecting your average, this can help even things out. So it should be a really good grade. All right, and then here's some examples. Now, I have done a version of this in years past. This isn't mine exactly. So these that I'm showing you are not ones that my students have turned in. This is based off this particular rubric that I'm using. So you'll notice here's the poster board, and it can be any color poster board you want if you want to go ahead and do that. Somewhere on there you have to have one large circle, the biggest one, that's your unit circle. And then you notice they put the other 5 circles, that would be a check mark. Out next to each one of these, they went ahead and did their work showing how you got that point. And, like I said, even this right here, that's a lot. It doesn't have to be anything huge. As long as I'm able to understand exactly why that point is the way it is. You can just talk about special right triangles. If it's a 30, 60, 90, the shorter leg is always half the hypotenuse, things like that. Okay. Just give you some examples. And, get creative with it. Like this one here, one person went ahead and made all these circles pizzas. Okay. It's creative, it's nice and colorful, it's fun. Now, I have no idea what the students who turned these in got as their grades. I would go ahead and tell you, though, if I got this one turned in, I would put an 80 on it. There are 2 boxes I couldn't check. There you go. For each of these 5 here, there's no explanation, so I can't check that box, and it's probably kind of hard to see, but they did put degrees, and they got the coordinates. Oh, but I'm just now noticing, it's so light, I didn't see it. They used a yellow marker. Okay, so I would actually give this one a 90, because I didn't see that at first. But just because there's no explanation for those 5 circles, I'd have to give it a 90. It's a great project. It's colorful. It's very creative. I thought something smelled fishy. Okay. I don't know, Brandon. Maybe they just did it for the halibut. For the halibut.
Pineapples did not belong on pizza except you had a pizza on a pineapple.
This one here, I really like this one. They did like a bunch of sunflowers.
Yes, they would.
Okay. Now on this one, I would probably go ahead and give it a 90 as well.
That's pretty.
Just because, you'll notice for each of these, they did go ahead and give an explanation, but they really didn't put a whole lot. Like I'm feeling if I didn't have a background in mathematics, I'm not sure I would understand what they were trying to say. So, there's too little, but then there's also way too much, something kind of happy in between. Okay, as long as I can understand what it is you're talking about.
The blue paper, that one was good.
The blue one?
Yeah. Slide 5.
Oh, and that one's just a kind of a zoom in on the other ones. And you'll notice here's one of those 5 circles. See, they drew the right triangle. We do need to identify it as, whether it's a 45, 45, 90 or 30, 60, 90. They gave a great explanation for these. I mean, now they didn't do anything but just add color to it, so it still looks great. Okay. That one would probably be 100. Okay. So there we go. That is our project. I'm going to give you 1 week. It's going to be due Tuesday. So that gives you through the weekend and an extra day should you need it. Okay. Hey. Uh-huh.
When do we get the poster board? Like, have we go and buy the poster board?
Oh, yeah, the poster board, yeah, I'm poor. You got to go get that yourself, yeah. Now, if you're having trouble, come see me and I'll see if we can work something out. Like maybe I can talk to somebody in the building, or maybe I can just run and grab one. I unfortunately can't buy one for everybody, but I could probably help a few folks out. Hey.
Oh, there's poster boards like this and like trifold boards at Dollar Tree.
Okay.
Especially at the one by the mall, they have like markers for that too and stuff.
Oh, really?
Yeah.
There you go.
What
Okay.
is this too?
Tuesday, so we have 1 week.
Tuesday.
Tuesday. Next Tuesday, I believe that's the 29th. No, 30th. That's the 30th. Okay. Tuesday the 30th. This is individual, so everybody will be doing one of these.
Mr. West can't afford a poster board for everybody, so.
No, they don't. Okay. All right. So any questions? Oh, no. We're actually going to go ahead and move on with the lesson. This is something you'll do outside of class. Now, if we finish up the lesson, maybe I can give you some time on Thursday. I think that would be a great idea. It just depends on how far we get. Okay. Hey, Chris.
And, like, leave them here?
Just bring them in and leave them? Sure.
Yeah.
We can absolutely do that. All right. Anything else? I got protractors if you need them. Rosie? It's got to be a poster board, yeah. Got to be a poster board. Okay. And, get creative. Really anything circular out in the world you can think of. Maybe a Ferris wheel. Wasn't it in here we talked about the vinyl records are coming back?
Yeah.
Maybe you could do something with a vinyl record. I don't know. Like I said, I haven't done this particular version. I've done versions of it in the past. A student of mine once did Captain America's shield. Okay. One student actually drew an entire minion, and the eye was the unit circle. So, just whatever you would like to do for the project. Make it creative. Hey. Well, I think just a standard size. Don't know what a normal poster board is.
Yeah.
I think they do, but just a standard size poster board. Yeah. Okay. Cool. You want to do one that big? My goodness, but okay.
Oh, you approve?
I mean, if you want to do it that big, I'd say that's a little too big, but you still got to have all those criteria from the rubric, so yeah. Okay. There you go. Just unfold it. There you go. All right, so let's see. We are at 12:17, so we'll get a little bit of time to go ahead and continue. What we've been talking about recently is evaluating trig functions for any angle. Now, for the unit circle, let me see here. We are restricting ourselves right now to just these 16 points. The 4 quadrantals and then the 3 points in each of the 4 quadrants. Okay, so why don't we go ahead and talk about the special right triangles for just a second. And these are not going to be 100% accurate, but that's okay. Wow, that took a while to get there. Let's see here. Let me go ahead and make that a little bigger. There we go. Okay. So the good news is when you're dealing with the unit circle, okay, there's only 2 types of triangles you're going to end up with. It's either a 45, 45, 90 or a 30, 60, 90. Okay. Now, if it's a 45, 45, 90, okay, remember the hypotenuse is always the radius of the circle. So the hypotenuse is always 1. Does anybody remember what the 2 identical legs for a 45, 45, 90 were? They are square root of 2 over 2, yes. Square square root of 2 over 2. And then when we're talking about the 30, 60, 90, let's say this is 30, this is 60. Again, the hypotenuse, the radius is always 1. Does anybody remember what's always across from 30?
What do you mean?
What length? So what's the length that's always across from 30 in the unit circle? Okay. Well, if someone said it, I haven't heard it, 1/2. Did someone say 1/2? No? Okay. Now, always across from 60 is going to be the square root of 3 over 2. Okay. All right. Now, the thing about the relationship here is sometimes we'll be working with circles that are not on the unit circle, so their radius may be a little longer, and that's okay. If it's a 45, 45, 90, you'll have legs of x, and then the hypotenuse would be x square root of 2. If it's a 45, 45, 90, and it's not on the unit circle. If it's a 30, 60, 90, but not on the unit circle, you have this relationship. The shorter leg is always x. The hypotenuse is always double the shorter leg. And does anybody remember, what do I multiply x by for the longer leg? The square root of 3. Okay. So if I were to go ahead and give you a triangle, let's say, bless you, 45, 45. Okay. And let's say I had, I don't know, legs of length 2. Just knowing it's a 45, 45, 90, well, what's the hypotenuse? Remember, it was x square root of 2. Well, here x is 2, so this would just be 2 square root of 2. Let's say this is my 30, this is my 60. And let's say that we have a length of, I don't know, 4. Now remember, what's always across from 30, that's your x in this type of triangle. The hypotenuse is always what? 2x, so double the shorter leg. So 4 doubled would be 8. And the longer leg is always that x times what? Square root of 3. So this would be 4 square root of 3. Okay. Now, let me go ahead and ask you this question. How many people in here are planning on going into calculus after this? Okay, one person. Okay, so I'm going to go ahead and decide then, because there's only one person, to go ahead and teach you this a particular way. And then Angel, just come talk to me at some point because I want to show you something else. Okay? All right, so let's say, based on these ratios, remember we're starting to move away from the opposite, the adjacent, the hypotenuse. We want to look at these in terms of y, x, and r. Remember, r is just the hypotenuse, the radius, yes. And on the unit circle, r just equals 1. And we also had this idea from last week that on the unit circle, we're not going to be labeling these coordinates as x comma y. We're going to be putting these as cosine comma sine. Every time you see cosine, you want to think x. Every time you think sine, you want to see sine, you want to think y. Okay. Well, a few things. What was a quadrantal angle? That was when you started to rotate and your terminal side stopped where? On an axis, yes. Okay, so you have a quadrantal here, 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 and here. So if you go ahead and rotate any radian measure or degrees and it stops on an axis, remember we call that a quadrantal. Okay. Now we also have a reference angle. We've seen these before. No matter where the terminal side stops, between the terminal side and the closest x-axis, that's what we call the reference angle. And it's always, always going to be positive, no matter what. So if your terminal side stops in quadrant 1, you'll use the positive x-axis. Here the angle is its own reference angle. If it rotates to the second quadrant, the closest x-axis will be this guy right here. If it rotates into quadrant 3, again, the negative x-axis. And then if it rotates into quadrant 4, it's the positive x-axis. It's always created using the x-axis and where the terminal side stops. That's your reference angle. Okay. Now, one thing I want to go ahead and do, since I'm not going to be teaching you how to evaluate these using the reference angle, I'm going to go ahead and just move on to some examples. Okay. So let's get some of these. So those are reference angles. We'll come back and revisit those if we have to. Okay. Oh, that's right, you did. Okay, I will take care of that today. I will get that for you tomorrow. Sorry about that. Completely forgot. Okay, now let's go ahead and do some of these. It says find the exact value of sine of 4 pi over 3. Now, I did put a good number of these on your test that you're going to take Friday, right? Okay. Well, the first thing, we're going to use the unit circle to help us identify what these are going to be. First, we need to figure out where 4 pi over 3 is. So if I'm looking at the unit circle, okay, I want sine of 4 pi over 3, right? Well, where's 4 pi over 3? It's in what quadrant? It's in the third quadrant. It's right here. So you'd go ahead and rotate all the way around, and here's your terminal side, right? Now, when we're asked to evaluate a trig function, you need to know what ordered pair is at that location. Whether it's degrees or radians, it does not matter. Okay? So here's the ordered pair that's there, right? I have an x value, and I have a y value. Well, the 4 pi over 3, he's going to help me figure out what ordered pair I want to look at. That's the first part. Now, the second part, the trig function is going to tell you what to do with that ordered pair once you get there. Remember what I told you, when you see sine, you want to think what? Y. Sine is always y, cosine is always x. So I want the sine, the y value, at 4 pi over 3. Well, what's the y value of that coordinate? Oh, that's the x value. So negative square root of 3 over 2. That's it. Okay. Now, what if I asked you for the cosine of 4 pi over 3? Then it would be the negative 1/2, because remember, what's cosine? Cosine is just the x. So all I would do is take the x value of the point at that measure. And it doesn't matter if it's radians or degrees. Okay. Yes? Oh, in degrees, that would be 240. So if I were to say sine of 240 degrees, it's still going to be the negative square root of 3 over 2. It makes absolutely no difference if it's in degrees or radians. So would the cosine of 240 degrees still be negative 1/2? Yeah. Okay. All right, well, let's try the next one. What does the next one say? Isn't it tangent of 150? Okay. So I'm going to come down here so I can write this. There are my ratios again. All right. We want the tangent of 150 degrees. Okay, well, the first thing, we got to figure out where 150 degrees is. Right, Rhett? Where's 150? In the second quadrant. So it's this guy right here. Okay, so we would go ahead and rotate. This is where my terminal side would stop, right? So I want this ordered pair. Okay. Now, before we go ahead and get to tangent of that, if I were to ask you, okay, what's the cosine of 150 degrees? The negative square root of 3 over 2. Cosine wants the x value, right? What would the sine of 150 be? 1/2. That's all there is. Now, the trig function is going to tell you what to do. We don't want cosine or sine. We want tangent. Remember, what's tangent's new ratio? It wants to take the y value and divide it by the x value. So from that ordered pair, I'm going to take that 1/2, the y value, and I'm going to divide it by the x value, the negative square root of 3 over 2. If you simply want cosine or sine, you just look at the x or the y. But if it's one of the other trig functions, you need to go ahead and use the ratio. So what happens when you divide by a fraction? You multiply by its reciprocal, right? So this would be 1/2 times negative 2 over the square root of 3. Okay, so see, the 2's are going to cancel. So it looks like I've got a negative 1 over the square root of 3. We need to do the thing. What is that? Rationalize. And we've done that several times before. So times the square root of 3, square root of 3. So negative square root of 3 over 3. That's how you evaluate on the unit circle. use the radian or degree measure to find the ordered pair, and then using that ordered pair, just do what the trig function wants you to do. That's all there is to it. Okay, Brett, what do you think? All right. Okay, well, let's try another one. Let's see, we just did tangent of 150. What else we got? Let me erase these. La, 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 don't look. Okay. So let's try secant of 15 pi over 4. Now, this one's interesting. Okay, 15 pi over 4. So I'm going to come back over here. Let me write it down here so I don't forget this. We want the secant of 15 pi over 4, right? Okay, but I'm looking at my unit circle. Where's 15 pi over 4? 270? Not 270. Okay. Oh, I'm sorry. You said 270. Yep. It's a Tuesday. He's absolutely right. Okay. It is 270. Now, you remember when we were doing the unit circle? If it was a multiple of 45, we counted by what? By fourths? Well, this problem, the radian measure, is given to me in fourths, right? So if I were to go all the way around, or, we can just go ahead and start here, this would be 1/4 pi, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. We just got to count to what? 15. So there's 8, 9, 10, 11, 12, 13, 14, 15. Okay. Wait a minute. This one should be 270. Did I miscount? 8, 9, 10, 11, 12, 13, 14. Hold on one second. I'm confusing myself here. 15 pi over 4 would be, that would go in there 3 times 3 3/4. No, that's right, yeah. It'd be 7 pi over 4, yeah. Okay. So it'd be this guy right here. Boom. Okay. All right. So there we go. Got it. So we located where the 15 pi over 4 was. Okay. Now, we want to use this ordered pair. It's the square root of 2 over 2, negative square root of 2 over 2. Let me go ahead and bring this down here. Square root of 2 over 2, negative square root of 2 over 2. Well, we found the 15 pi over 4. He gave me this ordered pair. What ratio does secant give me? I'm sorry? Lilybell's absolutely right. She says the ratio is 1 over x. Now let me take a step back. Secant is now going to be known as r over x, right? But remember, we're on the unit circle. What's the length of the radius? It's 1. That's why she said 1 over x. So if I want to know what the value of secant of 15 pi over 4 is, I want to take 1 and divide it by the x value of that coordinate. So I'm going to go ahead and put 1 over the square root of 2 over 2. But what happens when you divide by a fraction? You multiply by the reciprocal. So 1 times anything stays the same, so we don't need to worry about that. So this is going to be 2 over the square root of 2. And now we want to rationalize that. So square root of 2, square root of 2. So this would be 2 square roots of 2 over what? 2, because square root of 2 times square root of 2 would be 2. Those cancel. Square root of 2. Okay. Once you find the correct ordered pair, just do what the trig function tells you. Okay. Let's try one more of those. What was the one after secant? Cosine of 4 pi over 3. Okay. So I'm going to come back over here. Let me erase what I got. So I now want the cosine of 4 pi over 3. Okay. Well, first off, where's 4 pi over 3? Okay. So 4 pi over 3 is going to be right here. Okay. In fact, wasn't that the one we were just looking at? Yeah. So this is the ordered pair that I want. What does cosine want? He wants the x. So what's the x value at that location? That's it. That's all there is. Whatever the ratio tells you to do is what you want to do with the ordered pair you find there. Let me give you just a random one real fast. What if I said I want the tangent of 3 pi over 4? Okay, so first off, where's 3 pi over 4? Second quadrant. Okay, let me go ahead and erase this. So here's 3 pi over 4, or even 135 degrees. Okay, this is the ordered pair I want. There's my x, there's my y. Now remember, what does tangent want? He wants y divided by x. So I'm going to take that y value, the square root of 2 over 2, and I'm going to divide it by the negative square root of 2 over 2. Well, what's anything divided by itself? Okay, 1, but what's anything divided by its opposite? Negative 1. So the tangent of 3 pi over 4 is just negative 1. That's all that's involved in evaluating a trig function on the unit circle. Is this making sense? The assignment's going to be due Thursday. So we'll make that the assignment due Thursday. And I know there's 60 problems on here. You only have to work the circled ones. You only have to work the circled problems. So that cuts it down quite a bit. Only the circled ones. And we're actually going to make number 60 a bonus as well. It's due Thursday. So we still have a couple of days to get that done. We'll continue this tomorrow. So good. Good. Remember, when's the unit circle project due? Tuesday. So a week from today.